Our next topic comes from section 2.3, and we will be talking in section 2.3 about dividing polynomials, which again is most likely going to be review. So the first goal is for us to just sort of review how to divide polynomials. But the second part might be new for some of you, and that's going to be using polynomial division to actually find all the zeros. So to begin with, let's just talk about polynomial division. So let's get straight into an example. Let's just say I wanted to divide, let's do 2x cubed plus 7x plus 2. So here's one polynomial, and I'm going to divide this by x plus 2. We'll see some different formats for this and different ways of doing this. But to begin with, I really just want to relate this back to what we know and what we know about dividing. So let's go back to sort of old school long division. And just as kind of a recap here, we're going to actually relate this back to numbers. And then we'll look at how this works for polynomials as well. So let's take this first polynomial, 2x cubed plus 7x plus 2. Notice that it's sort of missing a term. There's no x squared term. So there's 0 x squared terms. This is just like if I had the number 2072. Notice how I have that 0 there? Well, I did the same thing with the 0 x squared, and so it's very similar. And then x plus 2, we could think of that as the number 12, because there's 1x and then 2. So we can think of that as 12. If you put 10s in for the x's, you would see what I'm talking about. Now let's just kind of refresh our memory on long division. You put the 12 over here, the 2072 goes there. You first see how many times 12 goes into 20 once, and then you multiply 1 times 12, you get 12, subtract them, and then you get 8. You bring down the 7. How many times does 12 go into 87? Now you're going to have to review some mental math. 7 times 12 is 84. You subtract those, bring down this 2, figure out how many times 12 goes into 32. That goes up top. 2 times 12 is 24. Subtracting those, we end up with 8. And so we write remainder 8. Alternatively, you might remember that this is 172, and we'll write it as 8/12. So it's kind of this mixed number. But anyways, doesn't really matter too much. Just wanted to show you, kind of remind us about long division. Works out pretty much the same with polynomial division. I'm going to write 2x cubed plus 0x squared plus 7x plus 2. And I'm going to divide this by x plus 2. Now notice that the 0x squared here, we actually call that a placeholder because we don't really include it, just like we don't say in the numbers 2,072. We don't write the 0x squared, but we really do need to include it if we're doing polynomial division. All right, so the first step is to figure out how many times x goes into 2x cubed. So we need to get x times something to give us 2x cubed. Now you can always divide in order to figure out what the something is, but most of the time it'll be relatively straightforward. It would have to be 2x squared in this case. So I'm going to go ahead and put my 2x squared up here. Now what I'm going to do is distribute the 2x squared to my x plus 2. Just like over with the numbers, we took the 1 and we multiplied by 12 to get the 12 down here. We're going to do the exact same thing, 2x squared times x plus 2. And I'm going to go ahead and write that down here, 2x cubed plus 4x squared. And just like with numbers, how this turns into subtraction, we would now have to subtract this. And so you'll notice this will always cancel, and you'll be left with the negative 4x squared. Then I bring down the plus 7x, just like I do with the numbers. And we basically repeat now. So now the question is x times what will give me negative 4x squared, and that would be negative 4x. I'm going to distribute that to everything, negative 4x squared minus 8x. We'll go ahead and subtract all of this so all the signs change. You can actually go through and change those to pluses if you want, but I'm not going to worry about that. Just know that that's what I'm doing. So these will cancel out, and I'll be left with 15x. We're going to go ahead and repeat this process again. X times 15 would give me what I need. Distributing that, oops, sorry, I forgot to bring down this 2 here, plus 2. Distributing the 15, I get 15x plus 30. Go ahead and subtract all of that. 2 minus 30 is negative 28. And so I could go up here and write down that my remainder is negative 28. So let's just recap what we did. We divided 2x cubed plus 7x plus 2 by x plus 2. So we did 2x cubed plus 7x plus 2 divided by x plus 2. And we ended up with 2x squared minus 4x plus 15, and we had a remainder of negative 28. This is not how I want you to write your final answer, but for now this will do for this problem, just to kind of illustrate how polynomial division works and hopefully remind you of that process. Okay, just to give us a better sense, I'll kind of flow through the next problem a little bit more quickly and show you a couple of the steps I'm doing along the way. I won't actually do numbers this time, but let's go ahead and try another one out. So we're going to take 4x cubed minus 2x squared plus x minus 2, and I'm going to divide this by x minus 3. Notice I'm using slightly different notation in this one. I'm using the straight line across to show that I'm dividing them this time. And so let's go ahead and set this up. We have 4x cubed minus 2x squared plus x minus 2 divided by x minus 3. So to begin with, we need to figure out x times what would give me 4x cubed. And it looks to me like that would be 4x squared. Maybe I can try to color code this a bit this time. And so that's going to go up here. I'm going to go ahead and multiply 4x squared, oh boy, times x minus 3. We would end up with 4x cubed minus 12x squared. So we're going to just slot that underneath. Go ahead and subtract all of this. This is a really key point. Don't forget that everything gets subtracted. So the first term will just go away, and I'll be left with the negative 2x squared plus 12x squared, which gives me 10x squared. Bring down the x. Now I need to figure out x times what would give me 10x squared. Looks like that's going to just be 10x, so we'll go ahead and add 10x up here. Next up, we're going to multiply the 10x by x minus 3, and so I end up with 10x squared minus 30x. Go ahead and slot that underneath here. First part's going to cancel out, so I'm left with 31x, and then I bring down the minus 2. Now we're into the final stage. We need to find what times x will give me 31x, and that would be 31, because 31 times x is 31 times x. Okay, and so now we distribute the 31. So I get the 31x minus 93. 91. also forgot to write plus 31 up here. All right, so just taking a look at this, looks like my remainder will be 91. Double checking that everything looks good. I think it does. Okay, so then my answer, going back to the original problem, my answer would be 4x squared plus 10x plus 31, and the remainder is 91. Now at this point, I've completed my intro for polynomial division, so if you'd like to end the video here, you can. I am going to, however, show you another method called the reverse tabular or box method, which you might have seen in a previous year in Algebra 2. So if you want to watch the rest of this video, it's just on an alternate method if you would prefer to do that, but if you feel good with long division, you can do it that way. Okay, so here is the box method, or sometimes it's called reverse tabular method. And what this says is if I take that last problem, which was 4x cubed minus 2x squared plus x minus 2, and if I'm dividing that by x minus 3, what we're going to do is set up a box like this. Around the outside of the box, we're going to put the factor x minus 3 over here, and then we'll put a line through the middle there, and then our answer is really going to go across the top. So out of the first box, we're going to get 4x cubed. Out of this box down here, we're kind of going in reverse clockwise order. We're going to get negative 2x squared. We need another box for the x. So notice I'm just kind of going term by term here. So I went 4x cubed, 2x squared, x. And now I know that I just need one more box because I need that negative 2. So I didn't necessarily know how many boxes I would need to start with. I did know that there were 2 rows because of the x minus 3, and then I just went around the outside. Now what we're doing here really is these boxes on the diagonal, the outcomes of those boxes when you combine their like terms should be these numbers on the outside. Except for the last one, because the last one will have a remainder that we'll have to add. So in order to get 4x cubed, let me go ahead and erase that. In order to get 4x cubed, this box has to be 4x cubed because nothing is being added to it. And so then what you do is you take what's in the box and divide it by that x over there. So 4x cubed divided by x gives me 4x squared. And that comes up here along the side. The reason this works is because we're actually looking at what's called an area model for multiplication, but we're just working backwards to do division in this case. You might remember using this when you multiply terms. You would put the two polynomials around the outside and then multiply them that way. Okay, so 4x cubed went inside. I think I'm going to try to color code this a little bit better, so I'm going to make this red. 4x cubed. So now that I know that I have 4x squared on the top, I can multiply that to get negative 12x squared in here. And then this tells me that something plus negative 12x squared should give me that negative 2x squared on the outside. And so if you figure this out, you should see that it would be 10, because 10 minus 12 is negative 2. And now I can figure out what goes on the top, because 10x squared divided by x is 10x. And we continue this process, so multiply that by negative 3, we get negative 30x. In order to get positive x, I have to add 31x, which then tells me the top portion has to be 31. And then finally, we can do this last part, negative 93. To find the remainder, we see that we have to add 91 in order to get negative 2. So that is the remainder. And you should notice that this was the answer we got above. All right, so that concludes my review of polynomial division.